Hello my dear PU1 students, welcome to Deeksha Karnataka YouTube channel. And if you are watching this channel for the first time, definitely you should like to subscribe to our channel, because this is going to be not only helpful for you for your upcoming PU1 exam, it will also be helpful for you in your upcoming second year PUC. It will be very helpful. All the students who are associated with our channel, definitely they are getting help in their PU2, and in between we have managed some time for you to prepare for your PU1 exam. Right now here I am giving you some very important questions for your PU1 exam. Now definitely it will help you to score well in your PU1 exam, but don't only rely on this. You have to see the model question paper solution that I have already done in our channel. A lot of questions to do in our session today as well. We will be doing 30 questions excluding numericals. There will be a separate video for numericals. So if you want to score well in numericals as well, you can check our special numerical session where I will be solving few important numerical questions. Okay, now this part is based on the previous year questions and model papers, previous model papers. Right now, as you know, from this year onwards, the board has discontinued the PU1 consolidated exam, where it was conducted across the Karnataka state. Now it is in the liberty of the college management that whenever they want to take the exam, up to them. They have given the date up before 28th February. The PU1 exam should be over. So based on that, many colleges are undertaking PU1 exam on different dates, right? And also I request you to join our WhatsApp channel. The link for this is given in the description. I will be giving you 15 standard MCQs. Don't expect that exact 15 MCQs will come, but some MCQs based on the similar questions, similar concepts, and maybe if you are lucky, you will get some MCQs from here as well, because all the MCQs we are doing are very important. But obviously, as you know, there are 14 chapters. There are a lot of possibilities of MCQs from each chapter. I have handpicked a few important MCQs for your preparation. This you can take just as preparatory, but 2 mark, 3 mark and 5 marks are definitely going to be very helpful. All the 2 mark, 3 mark, 5 mark questions are very important. They have come in your PU1 exam multiple of times. So let's start with the first part, that is MCQ section. We will see what are all the MCQs are. Which of the following statement is incorrect regarding the significant figure? So we have to see which of the following is incorrect. So very careful. They will give you incorrect. I have highlighted it, I have underlined it, but in your exam paper you will not see that highlight or bold letter writing. So you have to read it carefully. So 3 of the statements are correct, only 1 is incorrect. That you have to identify. So whenever you are answering MCQs, even if you don't know the answers, read the questions once or twice. Maybe you will find out some correct option. So I have seen students, they answer it complete illogical answers, even though they are not bad, they are good students. I have seen good students, they are making some very bad mistakes in the MCQ because some of his or her friend says that that answer is option A, so I marked option A. Don't do that. First of all, try to use your logical head. There is a very important part given in your body. So use that and try to figure out. If you are not able to figure out, then obviously you can take whatever means you find it good for you. Which of the following statement is incorrect? That means 3 is correct, 1 statement is incorrect. Which all the 3? All non-zero digits are significant. Obviously all non-zero digits are significant, so definitely this is the correct statement. All the zeros between 2 non-zero digits are significant. Obviously all the zeros between 2 non-zero digits are significant, so that is also correct. The trailing zeros in a number with a decimal point are significant. Okay, so basically they are saying 28.00, these zeros are significant. So maybe we are not sure at this point. I will skip it. Whether it is correct or not, we will see the option D as well. The power of 10 to the power is counted while counting the number of significant figures. So they said that suppose 2 into 10 to the power of 13. So they said that this is counted while calculating the significant figures. So now I am not sure about this, but I am sure that this is not correct. Why? Because if I write it like this, this is called scientific notation. In scientific notation, whatever is in the 10 to the power range, that is completely not significant. Only whatever is multiplied before that, that is only the significant digit, significant figure. So here significant figure is only 1. This is not significant at all, right? So definitely, as we know that this 0.00 actually represents the precision of the measuring, how close our measuring is to the actual value. So that gives you the precision. So this is a significant digit. So 28.00, this is significant. These two zeros are significant. But if you say 0.005, then in this case these two zeros are not significant. Okay, but when it is a whole number and that trailed by some zeros, that zeros are significant. Very, very important to remember. So obviously correct answer is option D, because 10 to the power 10 to the power numbers are not significant, but in this case they have said they are significant. Okay, so this is how you can use your logical thinking even if you don't know all the answers. Now the slope of the tangent drawn to the position time graph at any instant gives. So slope of position time graph, so suppose we have time, we have position, say x, and we have some tangent drawn at this graph. What is the meaning of this? So what is the meaning of slope of the tangent? Slope of the tangent means, what is slope? Mathematics, if you have learned slope, so if this angle is theta, then slope is basically tan theta is equal to delta y by delta x. Right, that is the meaning of the slope. Now here delta y is basically the position, that is delta x itself. Okay, and delta x is delta t. Okay, x is x-axis, so x-axis is t, y-axis is x, so delta x by delta t. What is delta x by delta t? So change in position divided by change in time. So change in position by change in time gives you the instantaneous velocity. It is instantaneous velocity. Okay, at that instant, this is the exactly at that instant whatever is the position and what is the time, right? Now average speed and average velocity are different. Okay, average speed is when you take the entire distance traveled and divide it by entire time taken, you get the average speed or average velocity. Okay, and instantaneous acceleration is not, and for velocity time graph it would have been instantaneous acceleration, right? In case of position time graph it will be instantaneous velocity. Now let's move on. The resultant of two vectors acting on a point is minimum if they are. So resultant of two vectors, suppose one is x, another one is y, they are acting on the same point. Now when the resultant will be minimum. Resultant means basically you are adding them. Resultant means you are simply adding them. Okay, now resultant will be minimum if they are basically acting in the opposite direction. Acting in the opposite direction means what will happen? The resultant value, the magnitude of the resultant will basically be x minus y if they are in the opposite direction. So one is in this direction, another one is in this direction. So x and y. So in this case what will happen? They will reduce each other. If they are acting on the same direction, then basically their magnitude will be maximum. Okay, and if they are acting in any other direction, their resultant will be somewhere in between these maximum and minimum values. Okay, so suppose this is say 2, this is say 1, then the minimum is 1 and the maximum is 2 plus 1, that is 3. This is 3, this is 1, and for any other angle the position will the value will be in between 3 and 1, right? So they must be opposite to each other, that is the angle is 180 degrees. Okay, so angle is 180 degrees, then you can say that angle is basically 180 degrees, they are opposite to each other, the magnitude will be minimum. Next question, let's move on to the next question. It's a statement based question, very popular these days. Vector addition is commutative. Okay, two vectors may be added graphically using triangle law of vector addition. So what is the meaning of commutative? Commutative means, suppose you are doing a thing that say x plus y, okay, and you are doing same thing, but now you have changed the order, y plus x, okay, and in case if they are equal to each other, then they are said that the function is commutative. If you are doing x plus y and y plus x, if they are same, then they are said to be commutative in nature. Okay, you will learn with the time that not everything is commutative, even though it is very obvious. For normal scalar addition it is commutative. For even vector addition also, it does not depend on the order. Okay, even if you add the y first then x next, you will get the same answer. Okay, so definitely vector addition is commutative in nature. Now second part, they have mentioned that two vectors may be added graphically using triangle law of vector addition. So we know that triangle law of vector addition, you can point one after another, then we can join them. Now this does not explain why this is correct. Okay, so vector addition is commutative obviously, and secondly they can be added using the vector law of triangle law of addition, obviously that is also correct, but this does not explain why they are commutative in nature. Okay, so that is why we say that both statements are correct, but statement 2 is not the correct explanation. So both statements are true, but statement 2 is not correct explanation for statement 1. So option B is correct in this case. If you see that, okay, both statements are correct, most students get confused if both statements are correct in that situation, whether it is a correct explanation or not. That is a very confusing thing, but if you are sure that, okay, it is explaining the first part, then you can say both are correct and it is correct explanation. If one of them is incorrect, definitely it will be either C or D. If both are correct but not correct explanation, then option B is the choice, right? Now a cyclist bends while taking a turn in order to. So when if you have ever driven a cycle, you will know that when you are taking a turn, if you just slightly bend, it helps you to take the turn easily. Why so? Because the options given here: reduced apparent speed, reduced friction, reduced speed, provide necessary centripetal force. So even if you don't know the answer, you can easily guess that speed does not reduce, friction is constant, friction depends on the weight, it does not change. Okay, so speed does not change, apparent speed is immaterial, whatever is apparent speed they have mentioned, but it is basically provide necessary centripetal force. So whenever you are taking a turn, you require centripetal force to complete the circular motion. Circular motion always require centripetal force. Even if you are taking a turn that is a part of a circle, not exact circle, okay, it is a part of the semicircle. So basically even that case also centripetal force is required. So that is why when it bends, some component of your weight is distributed and given as centripetal force. Now question number 6, a particle made to go around a circle with a constant speed with the help of a rope. The work done by the rope is. So you are if you have done this, like if you have taken a particle, anything, okay, tie it with the rope and then you rotate it in your above your head. Okay, we used to do that a lot. Then what is the work done? So there are two explanations to this, obviously. First of all, in a complete rotation, okay, the displacement is 0, and displacement is 0 means work done is 0. Other explanation is the displacement is in this direction, that is the tangential direction. Okay, the centripetal force required for rotation is in this direction, so they are perpendicular to each other, so work done is 0. So no matter what, work done is 0. Okay, this is called a no work force. So when you are rotating in a circular path, okay, centripetal force required for maintaining the circular path is basically in the perpendicular direction to the displacement. So displacement and force are perpendicular, so Fs cos theta, theta is 90, theta 90 means no work force. Next question, choose the correct diagram which shows the direction of angular velocity of a rotational disk. Okay. So we know that rotation is a vector. How to determine the direction of rotation? So your thumb will point in the direction of the rotational vector if your fingers curl towards the direction of rotation. Okay, so you have to curl your finger in the direction of rotation, then your thumb will point towards the rotational vector. So in this case, if you curl your fingers in the direction of rotation, then your thumb will point in the upward direction. So you have to curl your fingers, so that is the direction of the rotation, and your thumb is pointing upwards, so definitely it will be upward vector. So option C is the correct choice for this given question. Okay, slight idea of rotational vector, you can answer this question. Now next question, the work required to bring a particle of unit mass from infinity to a given point is called gravitational potential, gravitational constant, gravitational potential energy, gravitational kinetic energy. Okay, so now here they have mentioned a unit mass. So unit mass means this is gravitational potential. Okay, if it is any other mass, it would have been gravitational potential energy. For a unit mass, potential and potential energy are same, but the definition of potential is given for unit mass only, so definitely it is gravitational potential for any object. So if you are bringing an unit mass from infinity to any point in space, whatever work you are doing, that work is basically called gravitational potential. For any mass, for any particle, arbitrary particle, the work that you will be doing will be stored as gravitational potential energy of the system. Next question, again another statement based question. Statement 1, steel is preferred over copper and aluminium in structural designs. Okay, so copper is used in electrical wirings, whereas steel is preferred for construction, right? If you have seen their construction, they use steel rods inside in the concrete so that it becomes stable, right? Steel is more elastic than copper and aluminium as its Young's modulus is greater than that of copper and aluminium. Obviously steel is much strong as steel, and if you remember in the ancient days we used to have steel swords that we used in the fighting, right? Different kingdoms, different kings, they used steel swords, right? So steel is basically more durable, it has a long higher Young's modulus, that means it can withstand a higher amount of load. So that is why steel is used in the structural design. So basically the statement 2 is correct explanation of statement 1, right? As you can see from logical explanation, so both statements are correct and statement 2 is the correct explanation for statement 1. Okay, now let's move on to the next question. Question number 10. The pressure in a fluid at rest is the same at all points if they are at the same height. This statement is a statement of Bernoulli's principle, Pascal's law, Stokes' law, Hooke's law. Obviously not Bernoulli's principle, not Hooke's law, maybe between Pascal's law and Stokes' law if you are confused. So pressure in a fluid is basically given by Pascal's law. So this is the statement of Pascal's law. Pressure in a fluid in the same height is same, that is the statement of Pascal's law. Next question. Two thin blankets keep more hotness than one blanket of thickness equal to these two. The reason is, so if you this is a very old question, if you have learned it in your older class, younger class, when you are studying in 6, 7 and 8 as well, that two blankets keep you warm more than that of a thick blanket. Why it is so? Because there is a air trapped between these two blankets, and air is a natural insulator, and natural insulator basically gives you more warmth, right? So a layer of air is formed between these two blankets which is bad conductor. So that is the main reason that two blanket gives you a hotter atmosphere than a single thick blanket. Next question is this: which of the accompanying PV diagrams best represents an isothermal process? Very interesting question. So there are four different diagrams, and you have to identify which is the PV diagram for isothermal process. Now what is an isothermal process? In isothermal process, we know that in isothermal process PV is equals to constant. Okay, so PV equals to constant means what is the diagram for PV constant? So for diagram for PV constant is basically this one, rectangular hyperbola. Rectangular hyperbola, so at any point if you take P and corresponding V, and if you take another point with V and P, if you multiply them you will get the same value. That is why it is called rectangular hyperbola, and it is a PV diagram for isothermal process. In fact, if you consider the adiabatic process, that is PV to the power gamma, okay, graph looks same. It will not be rectangular hyperbola, but the slope of the graph will be more. That is the difference between isothermal and adiabatic process. You know that, right? So for adiabatic process the slope is more, so in that case they will give you different slopes and they might ask you which one is the adiabatic process. Let's move on. Molar specific heat at constant volume CV for monoatomic gas. So you can remember it using formulas. The best way to do it is that the smallest possible value is 3/2 R. 3/2 R is the smallest value for monoatomic gas. For CV, CP minus CV is basically R. Okay, so from there you can calculate CP, which will be equals to 5/2 R. This is the value for CP. CV is 3/2 R for monoatomic gas. Okay, next move on to the next question. In SHM, force is directed towards the opposite position, mean position, extreme position, origin position. So none of them make sense except the term mean position. So extreme position also makes sense, but extreme position is not the correct one. In SHM, whenever object is oscillating, okay, the force is always directed towards the mean position. That is why we say that force is negative, right? Because the displacement is in this direction and force is in this direction, so minus omega square x, we write it like this, right? So force and displacement are in the opposite direction, that is why there is a negative sign, so it always point towards the mean position. Next question. Velocity of a transverse wave in a stretched wire depends on tension of the wire, mass per unit length of the wire, radius of the wire, all of the above. So obviously velocity in a straight string depends on the tension, depends on the mass per unit length, it depends on the area. Area means radius of the wire. Okay, radius of the wire gives you the area of the wire. So basically all of the above is the correct answer for this question. Let's move on to the 2 marker section. Now we will be seeing 2 marker questions one by one. Write any 2 rules for writing significant figures. Okay, now whenever you are answering such questions, be careful, and if you remember that in the first MCQ question there was a question regarding significant figure, which one of them is incorrect. So last year PUC exam, okay, they asked similar questions. Okay, there was a question asked in the MCQ section, and the answer for that was given in the numerical question. One constant quantity, I think if I remember it correctly, they have asked about gravitational constant G. Okay, they remember it is 6.67, but student often forget what is the 10 to the power value. It is minus 8, minus 11 or minus 13. Okay, because in SI unit it's minus 11, in CGS unit it's 10 to the power 8, minus 8. So student often confused, and I have seen some good students making this mistake. Okay, they have answered this wrong. Okay, and sometimes I think there was one unit was given incorrect also, so they were trapped in the inside that question. And the irony is the answer for this was given in a numerical question where the gravitational constant based question was asked, and the value was given in there, and students were so occupied with all the other answers, they even forget, they don't even read that question, they didn't attempt at that question. But reading that question will help you to answer the MCQ question where you have made a mistake. So don't ignore any questions that is coming in your final exam. So read the question paper thoroughly. Maybe you will find a hint in the later part of the question paper itself. So be smart, be wise to answer such question. For example, this question's answer was given in the first MCQ itself. 3 statement was correct. Any 2 points you can write it here and you will get full marks. So I have chosen 2 options. All non-zero digits are significant. For example, the number 456, all 3 digits 4, 5 and 6 are significant. Just one example is added. Zeros between non-zero digits are significant. For example, 4005, all 4 digits, that is 400 and 5 are significant. Okay, so this is the 2 points. So this is just an example question. Okay, I have done few questions in my model question paper as well, so study them as well. You cannot ignore those 2 vectors of same units of magnitude, 9 and 5 units. What are the maximum and minimum magnitude of the resultant that can be obtained with these 2 vectors? Okay, very common type of questions. Obviously 9 and 5 will not come, they will change the values, but this type of question was very popular amongst teachers. So what we will do, 9 and 5 units. When we will get the maximum value? The maximum possible values is when they are in the same direction. So the maximum magnitude is 9 plus 5, that is 14 units. Don't forget to mention the units part, otherwise they will deduct marks. And the minimum possible value is when they are in the opposite direction. So one is 9, another one is 5. So the magnitude will be 9 minus 5, that is 4 units. Okay, so you have to mention that. Either you can draw the way I have solved, you can solve it like this, or you can mention in the words the maximum value will be when they are in the same direction, that is the magnitude is 9 plus 5 is equal to 14 units, and minimum value will be when they are in the opposite direction, that is 9 minus 5 equals to 4 units. Or you can just graphically represent, that is also considered to be correct, as long as you are able to explain that you have understood the question and then you have solved the question correctly. Okay, if you just write 9 plus 5 is equal to 14, 9 minus 5 is equal to 4, then maybe if you are getting good score, teacher might deduct 1 marks because you have not explained. But if you are failing, maybe teachers will consider and teacher will give you 1 mark extra. Mention any 2 advantages of friction. So in my model question paper I have solved how to reduce the friction, 2 ways to reduce the friction. Now here we have 2 advantages of friction. This came last year final board exam paper, PU1 board exam paper obviously. Okay, so in the model paper it was given write the 2 ways to reduce friction. So everyone has thought, okay, from friction maybe reduce friction will only come, so they have studied it, but they forgot to study this question, and in the final exam this question came. So be prepared. So how can friction be advantageous? Okay, friction is called a necessary evil because it helps in movement. Okay, so whenever we are moving, so for example I am walking here, so I am able to walk because there is a friction between the ground and my feet, and that friction force is pushing me forward. I am pushing the ground forward, in return the friction force is pushing me forward. That's how we are moving. In fact, all the motion that is happening, car, train, bus, they are all moved because there is a friction. Okay, friction force is actually pushing it forward direction. Friction allows us to walk, run and drive vehicles without slipping. Without it we would just slide around. Okay, if there was no friction we would only slide, would be able to slide, we will not be able to stand. Enables gripping and holding objects. For example, I am holding this pen in my hand. Why? Because there is a friction force between my fingers and this pen. If there was no friction, then this would have been slipped from my hand like this, right? So that is why when your hands are wet, it is difficult to grip something, but if your hands are dry, it is easier to grip. Okay, especially if you play cricket, you will know that if you are wearing a wet gloves, okay, and if you are trying to grip your bat, it is very difficult. That's why if you see in the cricket matches, the players keep on changing their gloves in between the overs so that they can still grip the bat. Okay, if the hands are wet, the grip is slowly lost. So enables gripping and holding objects. Friction between our hands and objects helps us to hold things securely, like a pen or a cup or a bat, right? Let's move on to the next question. Mention any two properties of elastic collision. So this is also very common question. What is elastic collision? Total momentum of the system before and after the collision remains the constant. So momentum is conserved. The kinetic energy before and after the collision remains the same. So this is the property of elastic collision. If they ask you the same question but they remove the part, they ask it inelastic collision. So in inelastic collision, momentum will still remain constant, okay, but the kinetic energy will no longer remain constant. So kinetic energy will change. So that is the properties of inelastic collision. If they say what are the properties of inelastic collisions, then you have to write that momentum remains conserved but the kinetic energy is no longer conserved. Kinetic energy decreases. Okay, now let's move on to the next part. State and explain the work energy theorem for constant force. What is the statement? The work done by a constant force on an object is equal to the change in its kinetic energy. Now imagine that an object having initial kinetic energy Ki was worked upon by some external force, and external force is F and the displacement is S. Then final kinetic energy of the system is Kf. Then from work energy theorem we can say that Kf minus Ki equals to W, or delta K is basically W. This is also another form. So this is the explanation. 2 mark question, do not required super heavy explanation, but minimum explanation is required. Only writing equation will not help you. Okay, but you try to answer as crisply as possible. Now, what is a Carnot engine? Name the working substance used in it. This is also a very common question. A Carnot engine is a idealized heat engine that operates on the Carnot cycle and is the most efficient engine possible under the laws of thermodynamics. Okay, so Carnot engine, let me know whether you spell it Carnot or Carnot. Okay, the actual spelling, the T remains silent. So one of our teachers, he used to say Carnot because that's how he learned, but we used to say Carnot because that's how we learned. Okay, both are accepted across universe, across world. Okay, so Carnot and Carnot both are accepted. So let me know if what your teacher teach in your class. So Carnot's engine is basically an idealized heat engine. Idealized heat engine means it is practically not possible, first of all. Secondly, it works on the Carnot cycle. So if you have seen the Carnot cycle, that has 4 steps. What are all the 4 steps? So it consists of 4 reversible processes. Very, very important to mention. 2 isothermal and 2 adiabatic. So in isothermal expansion, isothermal contraction, we also have adiabatic expansion, adiabatic contraction. So there are 2 steps. You should remember the Carnot cycle. So in between this question, you have to study the Carnot cycle as well. Check the Carnot cycle diagram. Based on that, maybe you will find a question in your final exam as well. So Carnot cycle, just a tip, Carnot cycle related questions might come. So prepare for that as well. This is not included in this lecture, but you have to prepare. I am telling you to prepare for it. Now, working substance of a Carnot engine is ideal gas. Okay, so ideal gas is the working substance. Okay, for example, if you are saying what is the working substance of a diesel engine, obviously diesel. Petrol engine, obviously petrol. But for Carnot cycle, it works under the principle of ideal gas. Okay, now let's move on to the next question. State and explain the first law of thermodynamics. We are still in the 2 mark state territory. Okay, when heat Q is supplied to a system part of it increases the internal energy delta U, and the rest is used to do work on the surroundings. Okay, and delta U is given by Q minus W, or you can say that Q is basically given by W plus delta U. This is the first law of thermodynamics. Whatever form you are comfortable with, you can write it down, but this is the statement, this is the form. This law is now you have to explain it. This law is basically law of conservation of energy applied to thermodynamic system. So if you apply conservation of energy principle into thermodynamic system, then that gives you the law of first law of thermodynamics. Okay, it states that energy cannot be created or destroyed, only transferred or converted from one form to another. So basically whatever heat you are supplying, that heat is basically a form of energy. Now what is happening to this heat? This heat is converted into useful work. Work is also another form of energy. We know that from work energy theorem, and whatever is left, that will be utilized by the internal processes, internal energy of the system. So internal energy of the gas will change. So internal energy will change based on whatever heat you are supplying and whatever work is being done by the gas. Okay, let's see the next part. So give the positions at which the potential energy of a particle executing SHM will be maximum and 0. So there are two positions where it is maximum and one position where it is 0. What are the two positions? Potential energy is maximum at the two extreme positions. So whenever, suppose it is a pendulum, okay, pendulum, whenever it is at the maximum positions from the center, okay, this is called the amplitude. This is the amplitude at amplitude plus and minus A. Okay, so if you consider this is plus A, this is minus A, so at these two positions the potential energy will be maximum and potential energy will be minimum when it is exactly at the mean position. So potential energy is 0 at mean position and it is maximum at the extreme positions. Right? Similarly, kinetic energy will be maximum at the mean position. Okay, if they ask you the same question about kinetic energy, now you will say, sir, you have not mentioned us about kinetic energy, you are not able to answer it. So I am giving you that hint as well. So kinetic energy is maximum at the mean position and it is minimum both extreme ends, opposite to that of the potential energy. Now state and explain Newton's second law of motion. Define SI unit of force. So this is a 3-mark question. This is the first 3-mark questions that we are going to solve. So how can we state? So the statement is very common and you have to practice it. Many students don't know the statement of second law. The rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of the force. Very, very important, it occurs in the direction of the force. Mathematically, we can say that F equals to ma. I like to say father equals to ma. So that's how you can remember father and mother both are equally important in your life. So father equals to ma is the Newton's law of motion. Now force is force applied, m is the mass of the object, a is the acceleration produced in meter per second. Now this is not over. You have to define the SI unit of force. So what is the SI unit of force? The SI unit of force is the Newton. Sorry, one mistake here. It is not capital N. It will be small n. Okay. If you mention capital N Newton, that means the Isaac Newton. Okay, it will be small Newton. Small n Newton is the unit of force. Capital N, only capital N is fine, but when you are writing the full Newton, it has to be small n. Okay, in case you don't want to write Newton, that is fine. Capital N is okay. Definition: 1 Newton is the force. Again, it will be small n. Okay, pardon for that typo. So it will be small n. 1 Newton is the force required to accelerate 1 kg mass by 1 meter per second square. So force equals to ma. So force is basically 1 Newton. So mass will be 1 kg and acceleration will be 1 meter per second square. Okay, so if the force required to accelerate 1 kg mass by 1 meter per second square is basically 1 Newton. Okay, the derivation of this we have done in the model question paper. If you have missed that out, please do check that. Now another question, prove laws of conservation of linear momentum using Newton's laws of motion. So let's start. The total linear momentum of an isolated system remains constant if no external force acts on it. Now we have to consider two bodies, object 1 and object 2. Okay, now it was approaching this with say a speed u1. They were approaching each other with speed u1 and u2. Okay, there is no other external forces acting on this system. Okay, no other external forces are acting on this system. Now, so we have to prove the conservation of linear momentum. So linear momentum is conserved. Now remember that this once these two objects come closer to each other, okay, they will collide, and after collision, suppose this is moving with the speed v2 and this is moving with the speed v1. It can be elastic collision, it can be inelastic collision, it does not matter. We are not interested in the type of collision, so it is valid for all types of collision. So during the collision, what is happening? This object 1 is applying a force, say F1, and this object 2 is applying a force, say F2. Okay, so F1 is applied in this direction and F2 is applied in this direction. Okay, so when they are colliding, they are applying force on each other. Now which law is helping us here? From the third law of motion, we know that these two forces should be equal and opposite. You have to mention briefly about these two forces about collision. So from third law of motion, we can write that these two forces are equal and opposite. So we can say basically F1 is equals to minus F2. Okay, F1 is equal to minus F2, that is the third law of motion. Now we will have to go back to the first law of motion, second law of motion. What is the second law of motion? Second law of motion states that force is basically rate of change of momentum. So rate of change of momentum means delta P by delta T. Now delta P we know that is basically mv by T. Okay, or m delta v by T. Now what is delta v? Delta v is basically final minus initial. Okay, that is by T. Final minus initial is the change. So this is basically F2. Similarly, F1 will be m 1. So this mass is say m1, this mass is say m2. Okay, so it will be m2. Okay, just for example. Now let's see what is the final speed of 1. Final speed of 1 is v1. So v1 minus what is the initial speed of 1? Initial speed is u1. Okay, divided by say after time t. So the collision time say t. So after say time t, what is the force F2? Force F2 will be basically, we have already calculated F2, right? So what is F2? F2 is m2 v2 minus u1, u2 by t. But there is a catch, there is a negative sign over here, so that negative sign you should not miss. Now this time collision time is same for both objects, so t can be cancelled. Now let me see. So m1 v1 minus m1 u1 equals to minus m2 v2 plus m2 u2. Right, now what we will do, we will take this negative on this side and this negative on the other side, so that everyone is positive, everyone is happy. m1 v1, now this negative sign comes to the left hand side, becomes plus m2 v2 equals to, now this negative goes to the right hand side, becomes positive, m1 u1 plus m2 u2. Okay, so m1 v1 plus m2 v2 equals to m1 u1 plus m2 u2. Now what is m1 v1 plus m2 v2? That is the momentum after collision. So this is basically final momentum. So this is basically final momentum. And what is m1 u1 plus m2 u2? M1 u1 plus m2 u2 is the initial momentum. So basically this proves the conservation of momentum principle. Now this is a 3-mark question, this is not a 5-mark question. So you have to follow the step by step. You have to start with drawing this diagram. If you can explain this diagram, well and good, but at least the diagram has to be drawn. If you don't draw the diagram, marks will be deducted. Now let's move on to the next question. Okay, next question is slightly easy. What is meant by range of a projectile? Give the expression for the same. What is the angle of projection for which the range of a projectile is maximum? Now what is the range? Range is basically the projectile is the horizontal distance it covers from the point of the projection to the point where it lands on the same horizontal level. So range is basically if you launch it from here and after some time it lands from here, this is called the horizontal range. The formula is basically r equals to u square sine 2 theta by g. So this is the formula. The range is maximum for theta equals to 45 degrees. Right, so range, if you put theta equals to 45 degrees, you will get sine 2 theta, that is 90 degrees, sine 90 is 1, so 9 sine 91 means that will give you the highest range. Okay, now derive, now we are another 3-mark question. Derive the expression for time taken to reach maximum height by a projectile. Another projectile related question. Obviously both the questions will not come, but one of the question is very high probability that one of them will come, because different colleges are asking different questions. A lot of possibilities are there. We are solving the most asked question from the previous years. So how can we calculate the highest? Suppose we are launching a projectile, okay, and what is happening? A projectile is launched, say, at an angle theta. Projectile is launched at an angle theta with the horizontal. So this component is, so this say u, so this is the x component, that will be u cos theta, and that upper one will be the y component. This is the y component, so this will be uy is equal to u sine theta. Right, this is the y component, this is the x component, and this is the height. This is the height, maximum height. Now if you see which direction is height, height is in the y direction. So while calculating the height or anything related to height, we will use the y component. Okay, we will use the y component. Now so when it starts from here, okay, its initial speed is this. When it reaches here at this point, what is the speed along this direction? What is the speed along the upward direction? This is the y component, right? Y component. Okay, this is the y component. Now what is the y component of speed at this direction? Y component of speed at this point is basically uy is become 0. That is why it is the maximum height. If it still had some velocity left in the upper direction, it would have gone in the more higher position. This is constant component. This component does not change. The ux component. Uy component is only changing. It is changing, it is decreasing up to this point, then it is increasing again when falling back. Right? So what we have to do, we have to assume that at the final position, that is at the maximum height, uy is basically equals to 0. Okay, so what we will do, we will use the simple equation of motion, that is v equals to u plus 2 minus at. Okay, why minus? Because as it is moving upward direction, the speed is decreasing, right? So speed decreasing means there is a deceleration or retardation, so that is why we have added the negative sign. Now what is v? Our final speed is 0, initial speed is u y sin theta, and what is a? A is basically the gravitational acceleration, that is g, and t we are trying to find out. So from there we can say that gt is basically uy sin theta and t is basically uy sin theta by g. So very simple derivation, not super difficult if you understand how to do it, and this question came in your as I said, last year's final exam. Okay, so if you solve it, you would have scored 3 marks, but students generally don't prepare for such questions, so they have lost the marks. Okay, now let's see the next question. Show that the trajectory, now we have completed all the 3 marks 2 marks question. Now we are into few select 5 mark questions. Okay, show that the trajectory of a projectile is a parabola, the most asked question across all the first few exam. Okay, so we have a projectile. So we have to show that the trajectory is parabola. Very important part. Okay, so this is not about finding any particular range or direction. We have to just find the parametric equation. So we will say that suppose the ux, this is how the projectile was launched. Diagram is important. The projectile is launched, say u. Okay, the angle is theta. Now the ux is this direction, so ux is basically equals to u cos theta, and u y is basically u sin theta. So these are the two components of the velocity vector. Now what we have to do, we have to find the trajectory, that is what is the relationship between x-axis and y-axis. Trajectory means relationship between x-axis, that is time axis, okay, and the y-axis, that is the height axis. Okay, so these two are the components that we have to find the relationship between. Okay, so first what we will do, we will start with the initial part, that what is the equation of motion of the y component. What is the, suppose at some time, after some time t, it reaches to a height, say y. Okay, then what is the formula for y? So y is basically given by what is the initial velocity in this direction. Initial velocity in this direction is uy. Okay, uy ut minus half gt square. Okay, so this is the relationship. Okay, y is equal to uyt minus half gt square. Now how this time is related, if you can replace the time in this equation with x, then we can find the formula for whether it is parabola or not, we can find that out. Right, now in the same time t, what is the displacement along x direction? what is the displacement along x direction. So y we have calculated, y coordinate we know. So to find the parametric equation, you have to find the coordinate x and y, right? Y coordinate we have calculated using this equation. Now what is the x coordinate? In the same time, how much distance it has traveled in the x direction. So the distance traveled in the x direction is basically x equals to ux into t, right? S is equal to Vt. So from there you can say that x equals to Ux into t, that is the displacement along the x direction. So what is the time t? Time t is basically x by Ux. So if you have observed, we have not put the value of Ux as of yet. We will put that at the last step, don't worry. So now what we have to do, we have to, this is say equation 1, this is equation 2, this is not equation 2. Sorry, this is equation 2, the time is equation 2, and what we will do, we will substitute these two back to equation 1. So from there we get y equals to uy into x by ux minus half g into x by ux whole square. Okay. So now you can put the value of ux and uy, that is obviously done in your books, so that is okay, but even without putting the values, you can say this is the equation of parabola. Why so? We will see that. So y is basically u sin theta and ux is basically u cos theta. Okay, so u cancels, into x minus half g into 1 by what is ux? Ux is u cos theta, but there is a square into x square, right? This x square. So we get tan theta into x minus g divided by 2u square cos square theta into x square, right? Or you can write this as y equals to ax square plus bx. Okay, y is equal to ax square plus bx. What is a? A in this case is equals to minus g by u square cos square 2u square cos square theta. Okay, and b is equals to tan theta. This is the equation. Now this is a general equation of a parabola. Okay, general equation of a parabola is represented by y is equal to ax square plus bx. Okay, you will learn another form of parabola, that is the common equation when this b goes to 0, only y is equal to 4ax square, that is also a form of parabola. Okay, x equals to x is equals to 4y square, that is also a parabola. But normally y is equal to ax square plus bx, this is the general form of parabola. So definitely the trajectory of a projectile is a parabola. Common proof, easy proof, full 5 marks if you practice it. Very common question, and there is a high probability that you will find this question in your final exam, because the teachers in the college teachers, they prefer these questions. Now derive the equation. There are two derivations, one by one. We will do graphical method. S equals to ut plus half at square, graphical solution to this. Only one single graph is there, so we will do that. So first we will do this one. We have a graph like this. Okay, so object is moving along this path. So this is initial speed, say u, the final speed say v. Okay, and the time taken, say t. So this is the t axis, this is the v axis, velocity time graph, vt graph. Okay, from vt graph we have to find the displacement. How to do that? In a velocity time graph, the area under the graph represents the total displacement. Okay, so this is the total displacement. How to do that? You can calculate the area by dividing it into a rectangle and a triangle. Okay, so this is a rectangle of this side is u. Obviously, if this is u means this is u. Okay, and what is this length? This length is v minus u. Okay, and the time given is here t. So what you have to do? You have to calculate the displacement. So from the graph, you have to draw the graph, explain the axis obviously, and then you have to use the triangle. The area under the graph represents the displacement. So here area under the graph means A, B, C, D. You have to name it. Okay, so first is area of rectangle A, B, C, D. So A, B, C, D, and then we have the area of the triangle A, D, E. A, D, E. That is the total area. Now how to solve that? What is the area of the triangle? A rectangle. A rectangle is basically length into breadth, that is u into t, plus what is the area of a triangle? Area of a triangle is basically half into base into height, right? So what is base? Base is time t and height is v minus u. So first term is matching, ut is matching, second term is not matching. So what you have to do? You have to do some steps to match the second step. Half into t into, what you will do? You will multiply one more t, and then what you will do? You will divide this with another t. Okay, multiply and divide this number with another t. Now t square obviously. Now what is v minus u by t? V minus u is basically change in velocity and divide by time. So it is a rate of change of velocity. Rate of change of velocity is basically, we know that is acceleration. So that gives you a t squared. So these two t multiplies becomes t square, and in the bracket you have to mention a equals to v minus u by t. Okay, so this is the first proof that we have done. The next proof is v square equals to u square plus 2as. Okay, so we have to do this proof from the same formula, same graph actually. Now the derivation is same as the previous one. Okay, we will say everything is same. Everything is same. Okay, so this will be the v diagram is same. This is v, and initially it is u, right? So this is v, this is u, and this is time t. So what we have to do? We have to find the we have to use the same logic that the area under the graph basically gives you the displacement s. Same thing, everything is same. Here it is v minus u. Okay, so what we will start with? We will start with the same formula, that is s equals to ut plus half v minus u into t. Okay, so this will be our starting point, but instead of replacing v minus u like previous one, the rest of the process is different. The starting point is same. So what we have to do? If you see here, no time is involved in the equation. So what we will do? First step is to take t common. We will take t common, and later on we will try to substitute t. Okay, so u plus half v minus half u. We have taken this half and we have multiplied it inside. Now plus 1u minus half u. 1u minus half u is basically half u plus half v. So basically you can take that half outside. So t u plus v. Okay, so this is the first stage. Now what we have to do? We have to replace this time t. How to do that? We have already learned that acceleration a is basically given by v minus u by time t. So what is time t from this equation? Time t from this equation is v minus u by a. So that same thing we have to replace it here. So it will be half t is given by v minus u by a, and here we have v plus u. Okay, so just slight adjustment. After doing that, what we will do, we will multiply this 2 into a with the other side, so we will get 2as. They are all in the division. Now they will come out on the left hand side, they will become 2as, right? Division to multiplication. Now what is v minus u into v plus u? Nothing but v square minus u square, right? So v square minus u square equals to 2as. Just reorganize. So v square equals to u square, this will come on that side, and we will rotate the side, so it will be u square plus 2as. So v square is equal to u square plus 2as. Graphical solution. Same approach, first stage is same approach, same diagram. Only thing is, after doing this, in one case we will substitute this v minus u with acceleration a, and in the second case we will substitute the time with the value of the acceleration and b minus u. That is the two different stages. Otherwise same steps, same problem, but both derivations are important for 5-marker questions. Now another 5-marker question, the last 5-marker question, but very important, very often asked, and students think that this question is difficult, so they ignore it. Write the Newton's formula for speed of sound in the air. Explain why and how how Laplace modified Newton's law for the speed of sound. So first of all, what is the Newton's formula for speed of sound? So speed of sound in Newton gave that it basically he assumed that the sound waves travel in isothermal conditions. So he assumed that PV equals to constant should be the condition, and based on that he formulated his formula for speed of light. Okay, so he said that it is basically P by rho. Okay, rho is the density of air molecule, air, and P is the pressure of the air. Okay, from there he said this is the formula for speed of light in air. Okay, so that was his formula. This is Newton. Okay, so Newton gave this formula. But if you calculate this using normal atmospheric standard atmospheric pressure and standard density of air, the value is very less. If it was calculated that the value was coming around 270. Okay, around 270, 280 it was coming around, but the measured speed of sound in air is about 340, which is much higher than that of this measured value. So how can Newton be wrong? Newton gave a theory, and from the theory we are getting a value. That value is not matching with the experimental results. So to our rescue, there is another person, another scientist called Laplace. He came forward and he solved this problem. So Newton assumed that the sound waves travel in isothermal conditions, that is constant temperature. However, sound waves compress and expand air rapidly, meaning that a heat exchange does not have enough time to occur. So instead of isothermal process, the sound wave propagates and follows an adiabatic process which is governed by the Laplace law. Okay, so Newton assumed PV is equal to constant, whereas Laplace says it is an adiabatic process. So he said PV to the power gamma is constant. Okay, and he said that the speed of light is basically speed of sound in air is basically gamma P by rho. What is gamma? Gamma is Cp by Cv, right? This is the Laplace correction, and if you just write this much, you will get full 5 marks. So this equation this small explanation, and then another equation. So only thing you have to make sure that why Newton was wrong. Newton was wrong because he assumed sound travels in isothermal process, that is constant temperature. But Laplace said that because sound wave travels so fast, there is not enough time for the sound to distribute the temperature. Okay, so temperature does change, and because of that Laplace said that it obeys the not isothermal but adiabatic process, and because of that adiabatic process he added this gamma into the equation, and everything changes, and our day-to-day value, measured value, is almost equal to the exact gamma of if you put the gamma of the air, okay, then you will get almost which is almost equivalent to diatomic molecules. Gamma for air is considered to be diatomic, so you get very close to the practical measured value. Okay, so that is why this is very, very important. One place Newton was incorrect, where scientists do take pride of, okay, Newton was father of everything, but if you can prove sometime Newton is wrong, definitely that is very pride for all the science community, right? Now if you are watching till the end, then definitely give it a thumbs up and subscribe to our channel. Don't forget that I will bring you the numerical questions, specially sorted 10 numerical questions from across the chapters for your PU1 day after tomorrow. Till then, bye.